Good afternoon, everybody. My name is Paolo Borin from buildingSMART Italy, and this session is called openBIM Collaboration Management Part 2. I will start the presentation. I'm sorry, but my presentation will be in Italian. So if you want the translation, you can go just outside and take the headset if you want. But if you want to discuss it later, there's no problem. The fact is that I just created the presentation in Italian, so it's difficult to speak in English right now. I will present also the other presenters, which are Mirbek Bekboliev, sorry for that, from buildingSMART Deutschland. Then we have Dario Garavaglia from Graphisoft Italy, then Emma Hopper from Bond Bryan Digital, and then we have Giulia Minnucci from NGSys, which is coming later because she has the game in the meanwhile. The presentation is about our working group, IF3 structure in Italy, and is about processi adatti per lo scambio informativo per il calcolo strutturale. Questi sono i miei riferimenti. Sono ricercatore all'Università degli Studi di Brescia. Sono responsabile per la Product Room qui in Italia presso IBIMI e da poco sono anche coordinatore tecnico di buildingSMART Italia. Ci sono i miei riferimenti, paolo.borin@unibs.it e il riferimento di IBIMI. Ho sempre una email con cui parlo in italiano o in inglese verso un pubblico internazionale che è paolo.boring@gmail.com. If you get bored, you can write me anytime. Quindi il problema di creare un gruppo che riguarda la disciplina strutturale in Italia, soprattutto per chi e perché. Il problema maggiore è che in Italia il mercato prevede una forte dispersione dei software di calcolo. Stiamo parlando di calcolo strutturale e analisi strutturale, non tanto di modellazione strutturale. Abbiamo un problema di processi, ovvero una pochissima, in questo campo, una pochissima diffusione di pratiche BIM e soprattutto openBIM, tranne rarissimi casi, e abbiamo un problema di tipo tecnico, ovvero un territorio che, come saprete, è caratterizzato da una fortissima sismicità. Gli obiettivi del gruppo di lavoro sono appunto unire le differenze dei software attraverso un approccio comune, openBIM. Da un punto di vista di processi, quello di fornire modelli di comportamento ai progettisti strutturali, e da un punto di vista tecnico dimostrare la fattibilità di analisi di tipo sismico in regime dinamico attraverso IFC. Siamo supportati ovviamente da alcune software house, da alcune università e da studi di progettazione, come vedete nei loghi. Si tratta di circa 32 partecipanti stabili, di cui 6 IFC or BIM expert, 13 domain expert. Per domain expert intendiamo progettisti strutturisti e circa 11 persone come riguarda software house, comprese appunto, come vi dicevo prima, anche 2 software house. Modalità di incontro: abbiamo fatto 12 meeting in 6 mesi, quindi siamo appena partiti con un progetto. Sostanzialmente abbiamo avuto 18 partecipanti di media riunione e ho preso circa come manager di questo working group 36 pagine di appunti e di minute. Siamo partiti da quali sono le criticità sentite dagli interlocutori in Italia. Il primo è un fatto che mi ha un po' sorpreso: è stato chiamato dialetti IFC dialects, perché il tema era esattamente quello di non avere una univocità di scrittura del file IFC, soprattutto per quanto riguarda le classi riferite all'ambito strutturale. Un problema riscontrato è la qualità e i contenuti dell'export di alcuni software che purtroppo non sono adeguati, nonostante modellino probabilmente le classi che si chiamano analitiche, e un livello della formazione dei progettisti, almeno in Italia, molto basso. Un'altra criticità è la comprensione dei principi ISO 19650 che Emma ci illustrerà tra l'altro più tardi. Ovviamente siamo partiti, come si dice, dai giganti, salendo sulle spalle dei giganti, ovvero l'idea che esistano già 2 MVD in buildingSMART International, forse un po' datate, ma che sicuramente presentano aspetti fondamentali, e da alcuni IDM già sviluppati in sede accademica scientifica. Siamo partiti da un flusso di lavoro, abbiamo deciso un flusso di lavoro, questo ha circa impiegato 3 mesi per poter essere creato, ovvero siamo partiti dall'idea di un progetto architettonico di massima che definisce anche quella che è la tecnologia edilizia, per poi essere ampliato successivamente. Questo progetto architettonico di massima dà lo spunto allo strutturista per fare le sue valutazioni e cominciare l'attività che è appunto di progettazione strutturale. La progettazione strutturale può essere fatta con software di modellazione BIM strutturale e non ha niente a che fare con l'analisi FEM, nel senso che il tema è che nel modello strutturale, oltre alle classi tridimensionali, ovviamente si vanno a inserire carichi, vincoli, eccetera, mentre l'analisi FEM è colei che dà la parte di sollecitazioni. Dall'analisi FEM ovviamente il percorso torna indietro e vengono pubblicati i risultati per andare in una fase successiva di aggiornamento, affinamento, dettagliamento dei modelli strutturali. Probabilmente per quasi tutti potrebbe essere chiara, ma vi assicuro che questa situazione all'inizio del gruppo di lavoro non era abbastanza chiara per tutti. E alla conclusione del progetto strutturale ovviamente vengono esposti 3 tipi di documenti, un documento che è l'IFC analitico, una parte che è l'IFC strutturale e una relazione di calcolo. È ovvio che l'IFC analitico poi può, ed è un focus del nostro gruppo, essere usata per le amministrazioni locali al fine della consegna del progetto di strutture, e ovviamente l'IFC contenente la parte tridimensionale strutturale viene validato nel sistema di verifica e controllo di progetto come previsto da ISO 19650. Per arrivare a questi dati abbiamo creato una serie di test e domande online in riferimento se tipi di modelli diversi possono essere adeguati alla realtà professionale, ovvero abbiamo definito un modello analitico e un modello strutturale BIM, e abbiamo cercato di capire quali erano gli oggetti del modello invece FEM, Finite Element Model. Ecco che quindi abbiamo 3 tipi di modelli che devono essere ben chiari quando si comincia a creare questo tipo di exchange information. Il primo è il modello BIM strutturale, che è prodotto ovviamente dal progettista strutturale, nemmeno questo era particolarmente ovvio. Poi c'è una seconda fase che è il modello analitico, che è una sorta di pre-processing della parte strutturale con l'inserimento delle parti geometriche e dei carichi, e da lì comincia un modello matematico totalmente diverso che è il modello FEM. Citando i Beatles, Misunderstanding All You See, numero 1, ovvero i software di analisi possono contemplare una modellazione ad oggetti. Questo era un qualcosa a cui non ero abituato e sinceramente non ci pensavo, ma di fatto il problema principale è che i software di analisi abilitano una sorta di modellazione ad oggetti. Questo ha creato un problema di vocabolario con i partecipanti. E quindi una volta compresi però quali sono i modelli in questo ambito strutturale, possiamo definire 2 tipi di software, sostanzialmente un software che chiamiamo modellazione BIM, che crea il modello strutturale BIM e il modello analitico, e un altro tipo di software che è quello tipicamente utilizzato dalla parte strutturale, che crea un modello analitico eventualmente ad oggetti e poi lo elabora in un modello FEM. È chiaro che se io ho uno solo di questi modelli o se il mio software produce uno solo di questi modelli, ho una criticità piuttosto importante, cioè se il mio software produce solo un modello BIM strutturale, allora ho bisogno di un traduttore analitico e quindi cioè una traduzione da classi IFC BIM, IFC Column per esempio in classi linea e nodo. Se ho un oggetto, se ho solo un modello analitico, ho bisogno di un interprete FEM e di un exporter IFC, quindi ho due problemi, e se ho solamente un modellatore FEM ho bisogno di un exporter IFC, quindi diventa così chiaro che ci sono delle criticità. Misunderstanding all UC 2, scusate il numero, al momento con alcuni partecipanti del gruppo di lavoro il modello BIM è solo il modello architettonico. Non capiscono che esiste un modello strutturale nell'ordine diciamo che viene comunemente dato da ISO 19650. A conclusione di questi 3 mesi circa di understanding del sistema, abbiamo costruito un caso studio in calcestruzzo armato gettato in opera, con 2 piani fuori terra e localizzato a L'Aquila per ovviamente il riferimento al recente terremoto. Questo è il risultato abbastanza veloce del sistema di gruppo di lavoro e quello che è il risultato probabilmente più interessante, ovvero un modello BIM strutturale completo con le armature e visualizzabile online all'interno di un common data environment, anche con i carichi che vedete in alto. Quindi effettivamente l'opportunità tecnologica è assolutamente presente, è sufficiente mostrare un flusso di lavoro che permette a tutti di vedere un modello strutturale completo, ovvero formato dalle classi strutturali, rebars, armature e quant'altro, e con l'applicazione dei carichi per un effettivo controllo anche in fase di call-out. Siamo entrati anche in aspetti un po' più tecnici per quanto riguarda la descrizione delle strutture, la fase di contenimento delle armature, per cui questo è uno schema di funzionamento del sistema di travata, ovvero la somma di più travi, andando a possibilmente richiedere alle software house di usare relazioni tipo IFC Rel Nests per quanto riguarda le travi all'interno di un'altra IFC BIM e poi di aggregare le armature all'interno di questa travata per dare una visualizzazione e una comprensione comune della relazione tra armature del calcestruzzo e le travi, e dare quindi un compimento logico al progetto di strutture, mantenendo l'impostazione da progetto classico, quindi non cercando di far variare ai progettisti il loro modo di progettare. È ovvio che è ovvio fino a un certo punto, ma il progetto vuole anche supportare il fascicolo, quindi la consegna del progetto strutturale, in quanto in Italia abbiamo bisogno di consegnare la modellazione dei materiali, dei nodi, delle sezioni e degli elementi finiti, delle azioni e dei casi di carico ai fini dell'autorizzazione in zona sismica. Tutto questo è chiaramente fattibile con IFC e lo Structural Analysis Domain, per cui a questo punto questo sarà un obiettivo del gruppo di lavoro e verrà inserito nella relazione finale. Prossimi passi, e qui concludo, la pubblicazione di una linea guida sia in italiano che in inglese questa volta, scusatemi ancora per la mia presentazione, la pubblicazione in use case management e l'eventuale pubblicazione di tutta la nostra knowledge base su BSDD. Sono tutti strumenti che come buildingSMART Italia siamo abituati a proporre e quindi faremo e produrremo per ogni working group da qui al futuro. Grazie dell'attenzione e scusate ancora per l'utilizzo dell'italiano. Mirbek, prego. Welcome on stage. Yeah, sure. You go next just present yourself.
1, 2, 3. Good afternoon. Buona giornata. Molto grazie. I mean, that's, I guess, all I can express currently. I need to practice. I tried to learn my Italian in the past. Without practice, you forget. So it's, taking the opportunity, I would like to thank IBIMI for this opportunity. And of course, I really keen to present our development in buildingSMART Germany, what we're currently facing or currently working at. So we really love to share our knowledge, and of course we're open to collaborate with our neighboring chapters and with everyone who is interested. So shortly about myself, I'm Mirbek Bekboliev. I'm a technical project manager of buildingSMART Germany. Trying to explain to you what we will do today, and my role as a coordinator within the working groups. We have various working groups. We have expert like working groups that are mainly experts, and short-term projects like project groups. We also have roundtables that are really like at the first stage, like incubation, and we of course have working rooms as well. It's exactly the same structure like we have at buildingSMART International. I'm also technical lead of buildingSMART International's building room steering committee, and I'm a firefighter and also actively involved in EU Climate Pact, spreading the word of EU Green Deal. So we'll try to explain to you everything now. Before we start, we all know it's everywhere that we need to explain all these abbreviations, and it's always good to have analogies. And I took that opportunity again to bring this analogy. In Italy, you all love cooking, and pizza is the most important here, I would say, and this is an analogy. When we have a use cases, and when we talk about structural engineering, I brought some use cases to you, and we need to explain it in simple language to our members, how, what should be delivered in which way. So like IDMs. And IDM is a recipe. You know how to bake pizza, right? You have process, you have your ingredients. You need to follow that ingredients, otherwise, and of course process, otherwise you will end up with something that's not a pizza, right? And of course, you have different types of pizza. You have different types of filters. Let's say I want carbonara. So, sorry, not carbonara. I mean, I have a pizza Hawaii or margarita. Then I put specific parts. I don't need a whole bunch of ingredients. And that's like a new like MVD, like ideas, specifying what I exactly need. And of course, we also had BSTD. It's a fridge. All that ingredients will be stored somewhere. That's exactly the same. So like I said, we have all these ingredients. As you can see in construction industry, we have, especially when we want to bring that, let's say, ingredients into machine readable way. Machine understands exactly precise information. It will not guess what you mean by 10 tons of concrete or maybe 100 tons of rebar, right? So you definitely need to give a precise information and measures and properties. That's really important. That's why we need to communicate with our members so they know what you need as a domain expert to deliver your requirements. So of course, software vendors, they know how to bring that into the computer, but you as a domain expert in structural engineering, you provide your requirements. That's really important and vital. Like you can see, it's a steel construction. I mean, it's not a steel, exactly steel construction, it's a prefabricated construction. You can see you can map all the necessary information, also related to structural engineering. You can put the related property set with their properties. You can, of course, extend them in BSTD, bring your own domain, like structural engineering domain, maybe which is currently not supported. You can extend through BSTD and bring your specific types, let's say, requirements that you can definitely map them together later on. As a global player, of course, we always need to focus on with our chapters, with international organizations, and we know that we have to bring our members to international, to bring our knowledge, and of course follow BSI process. That's very important, because without this process, we'll stick into our own country, and of course, it will be national IDM, national MVDs, but we need to find a consensus. That's the really most tricky part. Everywhere in all the countries, I should follow these rules. And when we bring the activity, that's why I'm explaining this, activities like steel construction, they might be same in some countries, they might differ from state to state. In some states, like federated states, like Germany, like USA, you have different states within the state, right? You have all that country. So you need to follow their rules, their own regulations. And there, of course, also BSD again plays a major role. Now I will focus on specific projects, like use cases that are brought not only from us, but also from BSI. Currently, we are trying to finalize detailed project proposal. Previously, it was activity proposal, steel construction. Maybe you have heard and maybe even used that some MVD was in the past implemented by software vendors like Tekla structures. You can definitely now export steel fabrication. And this was based on, released in 2012, real old one, let's say. It's more than 10 years. So we need to keep up with the new development. We need to update it. And of course, what we thought it should be, of course, IFC4. Currently, it's not so easy to cope up with all the implementation, but we need to focus on and we need to upgrade. So that was the main focus, the main idea behind this work. And as a basis, we thought, okay, we'll bring the model. That's what we are proposing. We will use existing MVD, like IFC4 reference view, and bring a model on top. And of course, later on, we'll put on top an idea so that we can filter our requirements. How this looks like, I will simply make it directly so we can simply read at the same time. We want to start from very beginning, when your design stage, so that at the end, you bring your model into the factory, and the factory, they will be able to fabricate it and partially deliver on site where it will be assembled together. That's really important. And then steel construction is really proved to be working as a proof of concept. The same way, well, I love to bring this analogy to timber construction. The principle is really same way, so that even our German working group of timber construction, they also expressed interest on this MVD and IDM and whatever we're doing IDF. They really want to do the same pace, bring, of course, some changes on top and do the same thing so that it will be consistent. That's consistency and harmonization will bring us a lot of advantages. How we work? Of course, we don't buildingSMART experts in openBIM, but domain experts are really important for us. That's why we are collaborating with expert associations like Bauform Stahl. They're exactly working on this topic, and they bring their experts. And we started working on some improvements, improving processes, checking the requirement, what is currently possible in an IFC, what is not, and of course, do some improvements. Sorry, I cannot zoom in, but I think I need the mouse for that. You will get anyways a copy of this PowerPoint presentation. So we try to optimize our processes to bring it to so that it will be up to date. In some cases, the new developments like PCF place maybe in the past was not so advanced. Now we can bring that. That's why you need to adapt and you need to always update your processes. It's not so easy, but you should cope up every day. And as you can see, we brought exactly the case when you start from the scratch. When you work with an architect like Paolo, you mentioned that you always have problems with architecture models, and later on you end up remodeling because for my for manufacturing purposes that will be not feasible. So you need to adapt. You need to have that MVDs, whatever we are proposing at the steel construction working group. Another example, another use case, recipe again, which is really, I'm really proud to tell that our working group initiated that, and we had many stakeholders from Austria, from Finland, also Italy. They delivered a standard that was recently, 2 years or already last year, recognized as a BSI final standard. You see the link there. They also published a use case on UCM, use case management. Whereas it's a use case management is again as a when we have all recipes, we have a cookbook, right? So all this use cases are structurally standardized way collected in one place, and you can filter, you can find really good recipes, you can find use cases. So it will be really good to do the same way when all others follow the same principle. Bring your use cases there. And this use case is exactly manufacturing and how to simply use IFC model for that purpose. As you can see, we started with the first use case, and this is not, of course, as a provision for void. It's a working group, it's small regional working group, and we brought this as a small use case. And you will find that the tricky part, what not all users know, you define, you bring them all into the processes. Of course, use software vendors. There are some different tricks. In the past, with old version of IFC, I mean, the previous schemas, you had to use IFC building element proxy and make it map it with provision for void. Now you have to use IFC virtual element, also provision for void. So you need to focus and you have to always keep up. One more use case, reinforcement modeling. This is exactly a really important one, because why reinforcement modeling is important, as you can see in the news you have seen, when it's not properly done, the building will collapse. It's your life, it's our life. So this is really important. And it's a good case when you do a modeling together with simulations, right? You do simulation, you do analysis, and that's a very good case when you bring your mapping in proper case, so that the mapping is very important. If I map it properly, I will not be able to import into my building. I have to remodel it again. That's what we don't want. Engineers, I'm an old engineer, I am a lazy engineer. I don't want to remodel. So I want to import my IFC model. I want to focus on exactly my expertise. I want to simulate, I want to analyze, I want to bring solution, not the remodeling, spending 60% of my time for remodeling. That's not the case. That's why it's important. So this is what the project I mentioned just right now that reached BSI standard, the precast concrete. There's working group, the multinational working group, also Italian chapter, Italian company was involved there, and many software vendors implemented it. And now there is a new start that one factory already did this implementation. They rolled out first slab, and they want to completely change their factories, all the locations. They want to put this automation into the process. As you can see, there's a double wall, there's a single wall, so there's a different kind of models that they implemented. Even for thermal bridging, there's a specific, let's say, thermal break that they used to implement also into MVD, because you need to keep up also with thermal bridging. It's really in structural engineering, especially if you're designing sustainable buildings. There are always some requirements, like in passive house, it should be thermal bridge-free construction. Then you need to find the solution, and this solution should also be available in IFC. So that was a solution, and they're really great to see that solution. By the way, this publication is available as an IDM, also as MVD schema at the BSI repository as a standard, and you can download it and you read it, that also in English. So as you can see, they prepared a video. I will not play that. You just check the video on top. You can later on play it, and they explain exactly what those companies wanted to deliver. They want to bring a solution. So that's not only a solution for one factory, let's say, but for an entire industry. I guess you made a screenshot, so I will definitely send you later on a link. Like I said, you find all that stuff on the standards library of buildingSMART International. Now, and of course, steel construction and sustainability, how they belong together? Well, that's the same principle. Steel construction, you can reuse, recycle, and of course, you need to reduce your waste. That is important. And it's not only steel construction, it's wood, that's all these things. And of course, the sustainability is a major and a really important part. And it's vital for everyone to bring new ideas. Reusing, especially reusing, as you can see, the container. If you have seaports in the utilities, there are major of them, a big ones of them, they have thousands of sea containers, then really commonly used and really widespread. So we can use it as a housing for disaster relief purposes. We have also a working group, like in Italy. They are focusing on some use cases. They're trying to bring common use cases that currently developed or published at the government level. We have, especially for infrastructure, of course, for buildings as well. And they try to reinterpret that use cases in perspective of structural engineering, because you can check use cases, you can, and you should, and you could adapt them. That's really helpful, because all that use cases also in UCM, use case management, you find, you inspire, you refer, of course, you give credits, that's important. You don't copy them and bring in your name under, but that's a really good thing as a use case management, that you can deliver your use cases in different languages. And of course, that's a minimum. In Germany, we put a minimum requirement to deliver that in bilingual way. So that's Italian, German, and English, so that our partners would be able to read them, and we're opening the door with that for collaboration with our chapters, with other organizations, and of course let them read and let them inspire and refer as well. So maybe even criticize, because there's an option in UCM under that you can leave a comment if you have read it. You need to register, it costs nothing, just do that. And as you can see, our working group focusing on specific use cases, and they started this simple use cases as a collection in one publication. It will be published sometime soon. And later on, they will extend that with process maps and exchange requirements. And exchange requirements, I guess they will use, of course, BSD for sure, and mapped it with IFC, and all that single use cases will be interconnected to each other, because they really need to be. And what is not here mentioned, that this is not, of course, an IDM. There's small use cases. They're on a small level of detailing, like if we need to know which information would you deliver, you need to have an IFC model. Just an example, you need specifications. They describe that kind of things. And of course, who should be involved in that use case? So this is all the publications. That's why it's not an advertisement. I just want to show you bring your publications as well, because users at the end should have a chance to read as an ebook. That's most of them also available as an ebook, because everyone reads after reading, and reading is always knowledge. So it's not just a use case management, but also publications that we really love to share, especially our white papers. So I hope I'm on time, and thank you for your attention. Thank you for your invitation. Really proud to be here. Thank you so much.
Thanks, Mirbek, for the inspiring and all the work that you've done for buildingSMART Germany. Next one, Dario, please. If you want to present from here or from here, you're welcome.
Good afternoon, everyone, and in this room, and good afternoon also to all the people remotely connected to this very interesting conference today.
1 second.
Okay.
The presentation will start. Yeah, here we are.
One. Probably in the back. Okay. Okay, my name is Dario Garavaglia, and I'm the Managing Director of Graphisoft Italy. My presentation today will be regarding openBIM in multidisciplinary collaboration between different teams. At Graphisoft, we have a vision. We believe that one day, also the buildings in our world will contribute to a better quality of life. And those buildings, of course, are designed and constructed by different teams, what we name a multidisciplinary team, around the world. So, considering this vision, our mission is to provide software solutions and services to enable those teams to create this kind of buildings. Graphisoft is part of the Nemetschek group. Nemetschek is a company that is embracing more than 12 different brands, covering the complete life cycle of an AEC infrastructure. In this slide, you can see in the first phase, what is named planning and design, you can see listed Graphisoft. And we are concentrated in this particular part of the life cycle. Then in Nemetschek Group, we also have many other solutions, also in the building construction of the infrastructure, and also on this phase named operate and manage. What is common in all those solutions is the BIM methodology. So an early adoption of the BIM methodology can assure that at the end of your process or at the end of the life cycle, you can create what we listen a lot in this conference, but also in the conference of the last year, that we were talking about digital twin. So if you want to have the possibility to manage your infrastructure, to have benefit of what you have created during the design and the construction phase, then the early adoption of the BIM methodology, and I would like to say the openBIM methodology, is a must. At Graphisoft, we have technology like ArchiCAD, our major platform for the design. But we also have DDS-CAD, that is thanks to a merge that we have done last year. DDS-CAD was part of the Nemetschek Group till last year, and now is part of our offering. And DDS-CAD is dedicated to the design of a plant, whatever it will be, from a small plant that you can find in an apartment till a big plant in an oil and gas company. Then we have our BIM Cloud platform, our real collaboration platform. So thanks to this technology, different teams from different parts of the world can work together in a single project. And then BIMX, our platform that is used to manage and maintain infrastructures. So part of a digital twin project, BIMX, is a very important component. I always remember the project that Minnucci Associati presented last year in Montreal of a digital twin solution. BIMX was part of this. Then we also have services associated to our technology, from the learning platform, where we teach our users how to use better our platform. But in the learning platform, you can also participate in a process to become BIM manager. So we have different level of certification that you can follow with us till being a BIM manager at international level. Then we have our forward contract. That is not really a simple maintenance contract. Are more services that we add in order to have the better you can have from our technology. And last but not least, our community, experts from Graphisoft, but especially from our user base, where you can ask maybe suggestion, or you can discuss, you can open up tables to share ideas and projects. So if we think about a project where we have different layers from the architectural point of view, or infrastructural point of view, or even the MEP point of view, then if you are able to do all those things together in the same time, at the same moment, then you are approaching this project as an integrated project or an integrated design. And this is what we believe is the future of the design. So in this small video, you can see how different people can work, compare, and based on their experience and their knowledge on a same project as a one team. Here is just an example. You can see many different aspects of a project done in a single model and in a single team. We are here because we really believe, all of us, that standards are important. We know IFC, how important it is in the openBIM, but there are many other standards that are important. And here you can see, for instance, a very important standard in the structural space. And this standard has been created by Graphisoft and now is public, so everyone can use it. So our technology, ArchiCAD in the middle, is able to communicate, thanks to this standard, to the majority technology in the structural world, like in the IFC way. So, and this is another step in the openBIM and being open to solutions. And what about communication? When you are designing, when you are doing a project, you need also to communicate. Different teams need to talk. And if you are forced to go outside your design platform to communicate to your team, is a wasting of time, and you cannot keep control of all the communication. With this other standard, BCF 2.1, you can, from the design platform, communicate directly with all the team that you have around the world. And this communication is tracked. You can keep control, and you can make sure that every single communication has been followed. So I was talking about the DDS CAD at the beginning. So as you can see here, this is another platform that is using the openBIM methodology to design plant. And this can be done for ventilation, electric, or sanitary and heating. So again, having many different experts working at the same moment in the same project, you can create what we like to name federated BIM model. So, and in this other important slide, I think, is exactly what we believe is important when we are talking about openBIM. So in this slide, you can see ArchiCAD in the middle, our platform for the design. And I'm sorry, are very small, the other picture, but you can for sure recognize IFC in some point, maybe SFA, I was mentioning before, and BCA and so on. But you can also recognize many other formats that our users are using, because of course they are free to choose the platform, the software, and the technology that they believe is correct for the work that they need and the tasks that they need to do. So we, as a provider, that we declare that we are openBIM, we need to make sure that our users can be integrated fully with the majority of the standard and the format used into the market. And today, ArchiCAD is like this. In this other video, you can see an example of federated model. So people that collaborate between each other, let's say, managing different components of a project, but also being in a very different place in the world. And we have many users doing this today with Graphisoft technology and services. And we really believe that the federated model is the nice way to do exactly what I was saying at the beginning, to create nice buildings that will increase our quality of life. So with this technology, our users are creating millions of buildings around the world, and we are very proud about that. Here in this example, you can see some of them that are very particular for different reasons. But of course, we also use our technology for our own. So in this last video that I will show you, you can see here, this is the Graphisoft office in Rome that will be opened in 3 days, the 1st of April. This will be a joint office between Graphisoft Italia and Minnucci Associati that will be open in Parioli in Rome. And this office has been designed and restructured completely using, of course, Graphisoft technology and services. But we also used, and we will use, the platform I was mentioning before, BIMX, to manage the infrastructure. Every single employee from Minnucci Associati and from Graphisoft will use the personal mobile to enter into the office, to open the door, to switch on the light, to regulate the temperature in the office. So we will really use what we are trying to, let's say, deliver into the market also for our own, because we really believe that this technology is very helpful for everyone. In this office, we will also have a very big room hosting more than 100 people, and this room will be dedicated to talk about BIM methodology implementation and standards. So it will be dedicated for, of course, normal reasons, so private meetings, but also it will be available for organizations like buildingSMART and openBIM if they want to organize with us events related to these standards and the divulgation of those methodologies. We will be more than happy to host also organizations like yours. And with this, I would like to thank you again, Minnucci Associati, for the very good work that they have done in working with us in this project of opening the new office in Rome. And we are available at our stand if you have any kind of question you want to share with us. And thank you very much again, and thanks.
So thank you, Dario. Let's go deeper in our openBIM management. Emma, please, the floor is yours. And congratulations for the title. I think it's great.
Thank you.
An explosion of information. So.
Let's just hope it lives up to the title then. So, hello everyone, my name is Emma Hooper and I'm Associate Director and Head of R&D at Borin Digital in the UK, where I work as an information manager, either on projects or helping clients within organisations. But I'm also involved with all this other stuff, and that includes being Vice Chair of buildingSMART UK and Ireland. And my focus over the past few years has been very much looking at how we can join everything up. So that idea of connecting and joining up is very much the theme of this presentation. In my earlier session, I talked about how we have most of the jigsaw pieces now, probably too many in some cases, and we kind of have a good idea of what the overall picture should look like. But we now need to finish that picture and work backwards to get all those pieces to fit together. And as always with my presentations, I ask you to focus on this word, information. It is a word we take for granted, a subject which is difficult to pin down and something we are completely overwhelmed by on a daily basis. And this thing we call information is fundamentally key to unlocking digitisation. But we need to start viewing information as an important asset in its own right, on par with a physical facility. And this all starts with clients. Clients procure buildings, bridges and roads, but they also procure the information that relates to them. And if that information is received in a way which is useful and there are processes in place to manage it, it can provide great value to an organisation. But it needs more attention. Unfortunately, I am starting to see organisations realising this. So for me, because I'm biased, I say it's the one true asset to rule them all. So what is information management? So to define information management at an asset level, we first need to think about it across an asset's life and its impact on an organisation. And this is both from an activity-based management layer, which people interact with, and then secondly, an information layer, which technology typically interacts with. And hey presto, you've got information management. Now, if we overlay some of the main standards, ISO 19650 occupies the management side, and then in the depths of the information layer, there are many, and this includes the ones shown, but there are many, many more. And for the rest of this presentation, we will look at both layers individually, and then how they work together. So let's look at the management layer, which I touched on in my session yesterday. So for this, ISO 19650 is a suite of standards, and it very much concentrates on information management, the whole life of an asset. And for this presentation, I'm going to focus more on the principles from parts 1, 2 and 3. So let's start with the common title of all the standards. The ISO 19650 series is all about information management using building information modelling. So there's two important concepts here. The first is information management, which is about specification, delivery and governance of just the right amount of information concerning the design, construction, operation and maintenance of buildings and infrastructure. And that's across all information, whether it's structured or unstructured. And then we have building information modelling, which is the process of managing the structured information within this wider information management framework. So it's essentially about managing all types of information across these three key streams: people, process and technology. And if I was to sum up ISO 19650, it would be about delivering useful information, because we're terrible at this as an industry, and reducing risk, because when things go wrong in construction, it's generally something to do with information. And for an industry obsessed with risk, it's barely ever thought about. The first thing to realise within the standards is that everything centres around appointments and not projects or work stages. Appointments can be on capital projects or appointments for other in-use trigger events. The main client of the project is the appointing party who is procuring the information, our information receiver, and then there is a lead appointed party who delivers it. So therefore, as we go down the chain, when the lead appointed party selects the next tier, they then become both provider and now receiver. And for this presentation, I will use the example that the appointing party is a client and the lead appointed party is a main contractor, but this is all dependent on the type of project. But who actually does carry out information management during appointments? Well, in the standards, it doesn't refer to a role. Instead, it refers to an information management function. And this function is made up of all the different information management activities which need undertaking on projects. And these activities get shared out to the most suitable people on the project. And this is to highlight the fact that information management isn't just the responsibility of one person, role or discipline. Anyone who provides or receives information has some responsibility towards it, and that's everyone. Now, from a process perspective, if we revisit the diagram from earlier and overlay the main activities, we have these cycles shown. So let's look at these in a bit more detail. So ISO 19650 is more responsibility is put onto the client to set up the information management ecosystem before any projects are started. And this starts with clients defining their information requirements. However, in the past, we've seen that some clients will ask for everything in the standards, others will ask the delivery team to tell them what they want, or others will just ask them for BIM. Therefore, more focus has been put onto purposes, whether that's to perform a task, answer a question or make a decision, to define more accurate information requirements. So let's look at information requirements in more detail. They're made up of both unstructured and structured information generated as a result of defining purposes. For structured information, it's object-based, so we need to specify the information against the objects, and this is where the use of the level of information need framework comes in, because this helps us to break the information down both alphanumerically and geometrically, and also enables objects to be related to documents. And then there is also metadata, which needs defining, and for unstructured information, the content can be specified. And this all needs to be considered in the context of when it is required and which appointment will deliver it. And ultimately, this creates exchange information requirements. And this is what it looks like in real life: a database of information requirements based on the level of information need and IFC product entities, with requirements associated to purposes and grouped into sets. And this is what we do on all our Borin digital projects. In addition to information requirements, there are other activities the appointing party must undertake. And I want to draw your attention to the reference information and shared resources, which is the information the client provides to the delivery team, and also the information protocol, which gets the requirements into contract. And this is all done before the delivery team is even selected. So when the tenders do go out, the exchange information requirements are used in the selection process. So as well as finding the most suitable organisations to design, build and maintain the facility, the organisations also need to be selected based on their ability to provide the requested information. The bidder applies through a pre-appointment BIM execution plan, and then the most suitable lead appointed parties are then selected. But before they start producing information, it is important to understand that within ISO 19650, the lead appointed party also has information requirements, and this is not well understood at the moment. In our case, the main contractor should take the client's information requirements and incorporate them within their own to assess the capability and capacity of their supply chain, and again, to allow the selection of the most capable organisations. The combined information requirements are then detailed further to make them practically deliverable. And this first step is about actually listing the actual deliverables. And this is done by taking the information requirements and using them as a base data set to create a master information delivery plan, a programme of information. And this is supported by a BIM execution plan, which is the how. And this is done in parallel with mobilisation and identifying information risk using a risk register. And all this planning is so that the delivery teams know exactly what information needs to go into the project and asset information models, and when as well. In ISO 19650, the deliverables are called information containers, and a federation of information containers creates information models. And when I say information models, in reality, this is just currently a dump of alphanumerical, geometrical information and documentation, all within unconnected containers. To exchange the information containers and build up the information model at a project and asset level, this is done within a common data environment. A CDE should be metadata driven both at a content and transactional level, and it is made of two aspects. So we've got the CDE solution, but this is likely to be many solutions, so it's distributed, and CDE workflows, and these are actions required driven by metadata which form audit trails. Again, in reality, largely, we're only using CDEs as document management systems and not true data CDEs. So many of these actions in the CDE centre around assurance and governance, and that's checking the information before it is shared between all the different parties. Before being handed over, the information also then needs to be checked against the Master Information Delivery Plan or the requirements using acceptance criteria. And then once authorised and accepted, the information models are handed over to the client where they are updated and update the wider asset information model, which is again stored and managed using the principles of the CDE. And this information is then used by various portfolio systems and used for reporting, being presented in many ways. Ultimately, ISO 19650 steps us through the client procuring and receiving their information through appointments. So now it's time to delve into the dark depths of the information layer, the fun bit. So the information within the information layer is complex and there's no getting around them. It's structured, multifaceted, multi-hierarchical, connected in many ways. The view of it changes according to its use. And as buildingSMART are well aware, this layer is key to interoperability and joining up the information puzzle. And part of this are schemas and proper information models. And when I say a proper information model, I mean this: a truly connected information model with relationships to other information sources like documents, classification systems, and other databases. This is everything we are striving towards with regards to information management, a true digital representation of a physical facility. And once I started to view ISO 19650 with this type of thinking, standards became so much more clearer. Information models from projects and other appointments should feed into a wide connected asset information model. Imagine that one model where a client can fully query and analyse the data for reporting and decision making, where operational based applications can plug in. So a client is in more control of their data rather than a technology provider dictating what is needed. But as I said, currently this is all disconnected and overlapping, and we are struggling to embellish it or edit information models post-design. So how can we achieve these connected information models? We need a schema behind them, so they're all connected. And do we have one in the industry? So we do. It's called IFC. So for any newcomers, IFC at its core is an object-based data model which provides the rules to give everything a unique place and to connect it all up. It contains three important parts: entities, attributes, all linked via relationships. And these entities can cover anything, including a door, a system, a whole facility, a task, and some even represent geometry. And there are some entities which allow us to connect to the outside world. We can link documentation to objects, therefore very importantly connecting structured and unstructured information. We can link to external databases, which will contain their own schemas and data like product manufacturers' data. And we can also link to classifications. Essentially, a classification tags the objects within the data model. But it's the relationships which make IFC so powerful, and we need to start thinking of them as just being as important as the entities or objects. I come across so much misunderstanding about IFC on a daily basis. It's either just a file format, a dumb 3D model, a second-rate classification, or just a bunch of properties. It's a schema specification, an object-based data model. Ultimately, it's a framework of connections. And because of this, I believe IFC is the key to the information layer. So we've heard about the management and information layers. Now it's time to bring them together. And there are many groups looking at aspects of this, but I just wanted to pull it together and share my own thoughts and ideas. And this is purely for further debate and discussion. So bringing both layers together, it becomes clear that all these activities in the management layer are around specifying, building up, updating and maintaining that connected asset information model across the life of an asset. So let's look at the activities from ISO 19650 again, but from the perspective of the information layer. So we start with the physical world, and this mirrors starts to form the foundations of the information management world, which gives us the building blocks of information across the what, why, when, and who, which can be represented by classifications or standardized taxonomies. And then through IDM to identify the use cases and the level of information need to define actual information, we could have standardized libraries of use cases and information requirements, a pick-and-mix modularized approach through the UCM and BSCD, which provides those specifying information a starting point. This is an idea we had a few years ago in the UK, but within the buildingSMART community, this is the AOH project, which is essentially doing a very similar thing. So taking these use cases, an organisation could build up a master information requirements database, which could span a whole portfolio of assets. This database needs to be built from a common schema using the principles of the level of information need. And this one source of requirements would then be filtered down in accordance with asset type, trigger events, sub-trigger events, and when we arrive at appointment level, sets of exchange information requirements for the selection of each appointment. After selection, information requirements from the client are shared and can be put into contract by standards such as ISO 12911. Next, the requirements are merged with the lead appointed party's information requirements to form an overall set for the appointment. This again gets filtered into exchange information requirements for the procurement of each appointed party. The response by the appointed parties is via task information delivery planning, which together with the appointment information requirements form the base of the master information delivery plan database. Filters could then create output task information delivery plans, so the appointed party has a focus on what they need to deliver. And then this can be also then communicated via IDS. What's happened there? Well, essentially, what then happens is the response to the task information delivery plans are the information models provided by the delivery team, and then these get checked against the master information delivery plan database, which is also connected to the common data environment, and those models get federated within the common data environment as a project information model. And then essentially what happens is the handover, the information from the project information model is then handed over to the client, where it is then checked back against the original requirements and merged into the client's asset information model. The information is then queried and visualized for reporting purposes or connected to other asset management applications for in-use tasks. Then another trigger event occurs and the process starts all over again. And this is happening continuously during an asset's life, and probably many in parallel as well. So the asset information model is constantly changing. But wait, there's something else. When ISO 19650 1 and 2 were first published, I produced this diagram to help me visualize the standards. And part of this, I saw a common data set which underpinned the main resources in the standards. So the requirements, the responsibility matrix, the master information delivery plan, and the information models. I didn't really know what it was, but I knew it was part of the answer of joining it up. So if we apply this idea to the slides we've just seen, it looks like this, a common thread throughout. So what is it? Well, looking at this using databases, I believe there are these schemas. So one for the information requirements, which is type-based. This is extended for information delivery planning with more focus on the aspect of time, which is then a mix of type and occurrence, and then our delivered information models within a proper CDE model server. And this is the type occurrence, but also with the values. And this wouldn't contain the data from other schemas apart from IDs or URIs. Now, we know IFC can be used for the delivery, and I've talked about it being used as that true information model. But could it be used with it throughout the entire information management lifecycle? And this is my question here today. We need a single information base. We can't have a future where we have many similar schemas doing the same thing, because that would be a nightmare. A common model would create standardized information requirements, which can be merged with other information requirements from that industry and lead-appointed party level databases. The requirement ID could be tracked all the way through each delivered piece of information, and then so it could be tracked back to source. Aspects like time and actor would become more granular, but would always be connected to the correct information, allowing information delivery planning. And then we could also do things like more robust checking and also querying of the information. There'd be so much more greater insight. So I've started to look at this to see if I could identify any IFC entities which might be useful, and I think these might actually have potential. And then whilst writing this presentation, it dawned on me that there's this other standard, 17549, which is also being developed. It's IFC based, but it's based on ISO 23387. So I'm just asking the question, could this have some potential? Possibly, I don't know. So just to wrap up, we now have a proper start in terms of connecting all aspects of information management. Otherwise, we're going to be completely overwhelmed, and it will be even more complex, and we will never solve the issues with interoperability. And part of this is recognizing that we cannot do information management without both of those layers, the management and the information layer. They have to be considered together. And then my final question, can IFC be used as that common data model? So I just wanted to end with a request to buildingSMART, in the fact that you've been so far ahead of the curve, but I really think it's now your time, and you just need to shout louder. You are the home of information and data science for the built environment, the home of interoperability. But most of the industry is actually oblivious to all this. So I think it's time to release the information layer and to get vendors in particular to plug into it and be that interface between people and the data models, and to get clients to understand that these standards exist. Thank you.
Thank Giuliano, wonderful presentation. Thank you. Next and last presentation by Giulia Minnucci. Please, you're welcome.
Is it working? Hi, everyone. Good afternoon. My name is Giulia Minnucci. I apologize for coming a bit late. I work for Engesis, which is an IT consulting and services company here in Italy, and I will be presenting to you today the project with which my team and other companies won the Asset Management Award program of buildingSMART last year, which is Course Life, Creation and Maintenance of an openBIM Digital Twin for Asset Management. Now, I'll give you a bit of context, and then I'll go more into detail about the project. So to start, we used a real-life case provided by our client, which is Costim Group, who is in charge of the construction of the whole Course Life Bergamo Smart District. So we're talking about a smart district, which comprises of a total 7,000 square meters area. The area has a lot of different parts, such as, for example, a residential area that you can see on top of the image. They also have a sports arena for esports and for like normal sports, team building sports, etc. Interesting fact is, from the sports arena on top of the residential building, they have a jogging area that is called sort of like sky jogging, where people, like residents of the district, can basically run on top of the buildings, which is a very nice thing that they have. They also have shops, commercial areas, parkings, external areas with gardens. So it's an entire district that is being rebuilt in a smart way. So everything will be connected together. It's the first of its kind, especially in Italy, of course. And it is currently under construction. You can see that an enormous investment has already been made, and it's said to have an important impact on the economy of the whole environment and the whole region. So end of construction should be at the end of this year. So if you're ever in the north of Italy and you're curious, you can actually go and visit, because it will be an open district. So this is the context. What happened? Yes, okay. So the idea behind all of this was to offer a building as a service through an integrated digital platform that will enable users to actually interact fully with the district itself. In this way, the smart district will allow users to, for example, use a wide range of services, such as booking their parking for their car through an app, or booking a table at a restaurant, or book the arena for a team play. They will be able to fully interact with the district through a wide range of apps that different providers are developing. You can see here that this is mainly the idea with the image that we provided. But how is it going to work? So to deliver this, there is a whole organization that is getting ready, relying on an IT platform called GSM. This platform connects several systems, such as the facility management systems, the BMS systems, the sensors that are all Internet of Things connected. And all these systems share the same base knowledge of the district that is derived from the digital twin. So the digital twin here is not only the BIM model, but it's the model connected with other systems, creating an ecosystem, okay? This is the main key that you have to remember throughout the whole presentation. We're talking about an ecosystem of different platforms connected through the digital twin. So how did we go about this? To bring this all to life, basically, we defined and tested an approach to develop the digital twin based on IFC. Why IFC and why openBIM? First of all, we needed BIM models to be integrated in several applications. So we were talking about ecosystems before, right? FM, BMS, various applications. So the BIM model needs to be interoperable. And then secondly, we needed to develop an open approach, because a closed approach would have required ad hoc integrations and ad hoc development for softwares, and most of all, a closed approach would not have been replicable over time. The client wanted to be able to use this approach not only for this district, but also to create other smart districts in the long run in other regions, okay? So openBIM defines a replicable approach, and the next digital twin will cost less, of course. So these are the main reasons. What is the approach that we actually developed? It's based on 5 steps. The first one was to understand which assets to represent. So we had to actually sit down with the client and understand their needs, because based on their needs, we could understand what was supposed to be represented. Then which information container for the assets, because for each asset, the client needed different information based on some use cases, based on some uses they needed to have with these models. And we wanted to organize this information in containers to be able to use them across different systems. So once we decided which containers, we went into detail about the information that was supposed to go inside each containers, step 3. And then, of course, we had to understand how the different systems that are integrated with the platform would actually read or interact with this information. So which system is the master system of the information, the point of origin, and which system is instead just reading the information or passively receiving the information. And then last step, but most important, how are we going to organize the digital twin? So this approach is for the whole district. And then we decided to, let's say, experiment this approach to see if it worked on a small proof of concept, but we went backwards. So what we did was first decide how to organize the digital twin, and then we went backwards through the steps until we found the list of assets. Now, let's go into detail about each step. First step, which assets to represent. Together with the client, we understood that there were lots of scenarios because we're talking about the district, right? So very wide area with a lot of potential users. But at the end, we found out that we have 2 main point of views. The manager point of view, so the asset manager, the manager of the district, and the user point of view, meaning, for example, a resident of one of the buildings, of one of the apartments. And then from there, we defined 39 scenarios, divided 50 and 50, mostly 50%. And then we established for each scenario if there was the need to visualize that scenario through IFC models or not. Then we went to analyze the scenarios more specifically, more in detail, and we found some smaller use cases. A use case could be, for example, from the point of view of the manager, receiving a maintenance ticket from a user and having to work on that. And on the user point of view, of course, opening a maintenance ticket or booking a parking spot, okay? Of course, when we analyzed these, we tried to focus more on the use cases regarding management, instead of use cases, for example, regarding, I don't know, booking a restaurant table, because that was less complicated somehow than the management aspect, of course. And the client also wanted to focus on the management aspect. So we established for each use case if it could be implemented starting from an IFC model or not, or from its visualization, sorry. And then from there, we selected the assets that needed to be represented in the model. So as you can see, we found 246 asset types, 90% of which were included or were to be included in the IFC models. For each of these asset types, we went through the mapping to IFC. So we found the IFC entity and the predefined type. And then we defined requirements with the clients about shape representation and information requirements, meaning properties associated to the asset type. Regarding properties and information, we needed to understand what kind of information, how it could be organized, and if we could organize this information in containers that could be, let's say, that could be impactful for different systems. Now, don't focus too much on the matrix because it's really detailed and complicated, but the main part here is that we found 17 containers of information. So for example, one container is shape and geometry, meaning it contains properties about shape, geometry. One other is, for example, static data, meaning all the static data, all the static information regarding an asset was organized in one property set, and so on and so forth. So we found 17 of them, okay? The matrix here was used for us because for each of these containers, then we needed to decide where was the information included in the container originating. So you see here that we have the middle part of the matrix with the trigger events. What does it mean? When we look at information, we need to understand where is this information originating, but also what happens if I need to change it. Or is there an event during the life cycle of the asset that will change the information, create the information, or delete the information? Those for us are all trigger events. And each trigger event is basically, let's say, managed by one of the systems that was integrated in the ecosystem. So from there, we needed to analyze all the applications and the systems involved. And we needed to understand, okay, this is the system that triggers the creation of the information, whereas this is the system that receives this information. So it passively receives it, but then somehow is the one that will change it during the life cycle. So each system is either master or slave of that specific information container. How to organize information in the containers. We decided to try to simplify things, let's say, and we identified 4 categories, let's say, of property sets. So those 17 containers that you have seen, which basically represent property sets, have been divided in these 4 categories. We have general data that has all the information that uniquely identifies the assets. Then we have static data, meaning all the properties that are relevant for the management of the asset, but it's an information that doesn't change during the life cycle of the assets itself. And then we have dynamic data, which the name itself is kind of like self-explanatory, meaning information that is useful for the management of that asset, but does change during the life cycle. And that is the tricky part, because dynamic information we found is either coming from usage or from design. So if we have dynamic information from design, it means that I have set already that information during my design phase, so I can potentially introduce it in the model, but I have to know that it's dynamic. It will change during the life cycle of that asset. So at some point, some other system will change the value of my information, will change the information itself. So do we want to include it in the model or not? And then dynamic data from usage, it's probably an information that I don't already have during the design phase, but will pop up at some point during the asset life cycle because I have an integrated platform of systems. So at some point I will have a sensor that will give me some information about an asset that I didn't previously have. So do I include that in the model or not? This was the kind of analysis that we had to do. So we decided to have all this information somehow preset, in the sense that I could define that there is that container, so I can ask whoever models the asset itself to, let's say, leave a spot for that information, but some other system, so not the model, will actually, let's say, include the value of the property, okay? Next step, systems. So we said that some systems will create or change or delete. This is the systems that we used for our test. So we have the BIM model coming from a BIM authoring tool. Then we have the Azure digital twins that we used to actually create the digital twin. As you can see, is the brain of the whole operation. It receives information from the IFC model exported from the authoring tool and sends information to other softwares such as FM softwares or BMS. And the information goes both ways. We had to develop a software map where we define the flow of data from a system to another, because we needed to understand that the Azure Digital Twin, so the digital twin itself, is the core of the whole process. So IFC here was not only used as a format for data exchange, but also as a common data model among the BIM model and all the other systems, okay? An example of how we use the Azure Digital Twin. So 58% of the information to actually create the digital twin was coming originally from the IFC model. And then we had to divide the information. Some of them was mainly capabilities from the rec ontology that the Azure Digital Twin already had. Some was from IFC, and some other was coming, as you can see, from the extensions from other systems. So if you look at the Azure Digital Twin as the brain, I have some already structured data, and some data will come up during the life cycle of the asset, okay? All of this was possible thanks to IFC, because it actually allowed us to have a consistent update of the data through time and through the systems. It's based on a standard which is commonly used, so that also allows us to replicate it in different contexts with different systems, for example, and also there is no semantic transformation if there is any change or update on information. Now, I will show you briefly the test that we did. We selected one apartment of the whole district because it was really too big. We filtered the assets the client wanted, selected them for one apartment, designed the model, put the assets in there with all the relevant information, exported the file in IFC. So in total, we had 36 IFC elements in the model. We used only 4 use cases out of the 40 that you saw before, that are part of 2 scenarios. This scenario is a user in the house opens a maintenance ticket, and the manager receives the ticket. Now, I will not go into the technical details, but I can show you a brief video of how this is supposed to work. How do I turn on the video? Automatic, perfect. So here we have the operator, the maintainer that receives an alert. In this case, the alert says the temperature in the apartment is beyond the comfort limit. So he clicks on the notification and he can see directly the information about the sensor in the model of the apartment. He checks temperature and humidity above or below the levels that are really acceptable. He checks if there is a window open because they have sensors that tell them if the window is open or not. In this case, it's open, so it could be the reason why the temperature is too high. But just in case the window is closed, here I will do this manually, but normally it's the BMS that through the sensor gives the information to the digital twin. Now, just for the test purposes, we did it manually, but in this case, we simulated a closed window. So let's say the BMS tells the digital twin the window is closed. So when I go back to my model, if the window is closed, the new status is shown in the model. But this also means the temperature is not due to the window being open. So if a window is closed, I can check the air system. And this is what the operator does, goes to the air system machine, checks if there are any tickets open. Apparently, it's not working because this is the status shown. And then there are no maintenance tickets regarding the fact that the machine is not working. So the operator can actually open a ticket inside the model because it's all integrated, right? He can input all the information about the maintenance ticket that needs to be done, save the ticket, and that ticket will be automatically saved on the facility management system that is integrated in the digital twin environment. In this case, we used openBIM for the test. The operator can see, for example, the ticket in the dashboard and assign the task to the right team. And then you can see the task opened in the model. And then the maintainer has 2 choices. He can either work the task on the FM software or input all the information about the task done directly in the model. Sorry, I'll be quick. So key outcomes of this, and then I'm done. I will leave you with some information. So we do believe that openBIM is a driver for innovation, and we believe that we have shown this with this small project. As you can see, IFC is a data model, is common data model, of course, used to integrate different solutions. We have seen how different solutions that are normally not, let's say, IFC oriented could actually use the IFC schema, such as the Azure Digital Twin. And then for future endeavors, we think that this process could be replicated in other situations with different softwares if you want, and possibly include some other standards such as BSDD and external classifications. I would like to thank all the team members that participated in the project, Minnucci Associati Engineers, Angie's, my team, IBN, and of course the client Custom. And I'm done. Thank you, everybody.
Thank you, Giulia, for the wonderful presentation. Okay, let's go to the end. I see really tired faces. So any question from the people inside? Any curiosity? I don't know. Okay, let's go home, I think. Or drink, or whatever. Thank you, and let's quit this session. See you maybe tomorrow around. Good evening.